Hey class, so here we are in Unit 9. So the goal of Unit 9 is to start working in numerical methods. So we're going to look at linear algebra and numerical integration and differentiation. But before we get into that, there's just a few little odds and ends I wanted to share with you for working in Python. So we've kind of viewed Python thus far as a normal programming language. But one of the reasons why people enjoy Python is that there's a lot of little niceties or a few features that make Python quite easy to use or convenient. So we're going to just take a look at a few of those in this lecture. So I call it advanced Python, but these are just sort of standard things that people use in Python just to make syntax and life a little easier. So we've talked a little bit in lecture about becoming Pythonic or becoming Pythonistas. So there's a nice little Easter egg in Python. Is that if you do import this, there's a Zen of Python, which is a poem. So I'm not going to read to you the poem, but it's kind of like, you know, what is the goal of Python? So in some programming languages like Java, the goal of Java is to be object oriented in all situations no matter what. So object oriented programming is a style or a paradigm for programming. In Python, the goal of Python is to be convenient, practical, and powerful. And this poem here kind of tries to express that in a fun way. And so there's, for example, practicality beats purity, or readability counts. Sparse is better than dense. And Python is kind of like, I would say, programming designed for humans. Like it recognizes, that humans are not, absolutes, and there's certain things that we like and certain things we don't like. And so I think Python's a really great programming language because it's designed to be used by humans instead of adhering to some paradigm or being as close to the machine as possible, like C is, or other examples. Okay, so just a little fun poem to read. Take a look. Okay, so now we're going to just view a few idioms or little bits of Python that make our life easier. The first one is iterating lists with enumerate. So a lot of times we'll have a list, like I have here a list, my list. It's a series of strings. And I often want to have an index for them. Like I want to have, when I work with high, I want an integer 0, or maybe if I work with this, I want an integer 1. And the reason that I want this integer could be lots of things, like maybe I want to find out what is the second element in the list. Okay, or maybe I want the integer because I'm counting how many times I saw, or I'm looking for where is the shortest string. And in that case, I want to keep the index for each element. Whatever the reason, we can use this special syntax called enumerate. And when we put enumerate around a list in a for loop, we now have two variables each time through the for loop, I in this case, which is giving us the integer, and E, which is giving us the element in the list. Okay, so I use I and E because it's a little mnemonic. I stands for integer, E stands for element. But you could use, again, whatever variable name you want. This could be J, this could be the name index, it could be J, K, whatever you want. Okay, so normally when we do a for loop, we don't have this enumerate thing, and we have a single variable here. So we could see an example. I'll just show you guys a little example here of what it looks like normally. So if I were to take this list, normally I would do for E and my list, print E, and you would see, each time through the for loop, I have an element from the list being printed. But then when I put enumerate, okay, notice I'm keeping just one variable here. Now I have two things in E. I have the index and then the element. So to make it easier for me, I usually put an I here so that the two things are separated. Okay. So now I can access the element in the list, hi, this is, and then I, the integer for each element list, 0, 1, 2. Now, in this example, there's no need to have the index, but I'm just saying sometimes, we've seen, like, for example, when we were computing, I think we were finding like the smallest element in a list. It would have been convenient to have I, because otherwise what we had done previously is we had to do something like this. We had to make the variable ourselves, and then we would keep track of it ourselves. So we would do I plus equals 1, print I, E. right? We would just keep track of it ourselves. But this is just an easier way to get around that. Okay, so there's our first example of how Python can make our life easier with the enumerate syntax. Another thing is if we have two lists. Okay, so here I have two lists, X and Y. I just used range to make some lists. I can use zip, which allows me to iterate over them simultaneously. So now I can have elements in both X and Y in my for loop and iterate over them simultaneously. This is pretty convenient. Okay. So in the past, what we may have seen is like you may have had to do, like if I had X equals, we would have had to do something like this for I in range length of X, xi equals xi, yi equals yi, and then just print, then we could have access to them. Okay, so what we had to do before was we had to make I, which is an integer we can use to slice the specific ones we want or to index the specific ones we want. But with the zip syntax, we can actually combine any number of lists together and then iterate over them simultaneously. Again, notice we have this sort of special syntax here where we have two internal variables in our for loop. We have an xi and a y, just like last time we had, I and e, two internal variables in our for loop. Whereas normally in for loops we would only have one, but see, we can have multiple ones. And if we had three lists, we could do three of them. See, piece of cake. All right, so enumerate and zip. The next one is list comprehensions. List comprehensions are a shorthand for a for loop. Sometimes, we have sort of a quick for loop we need to do, and we don't want to bother writing it all out. Okay. So here's an example is like, let's say I want to compute the powers of uh, the integers 0 through 4. Okay, so when you're doing a list comprehension, the first thing is that you surround a statement with brackets. So you surround a statement with brackets. So your result of a list comprehension is a list. Okay, so a list comprehension always outputs a list. Then we have inside of the square brackets, we have a statement that will be run multiple times. So this is like the inside of a for loop. Okay, maybe I'll write this code out as a for loop so you can see what it looks like. So if this were a normal one, I would do this, like my list. So this is how I would normally write this statement out. Sorry, hold on. Oh, okay. This is how I would normally write this out. So this is the snippet of code we're going to run. That's the snippet of code. Notice that it knows that each element in the output list will correspond to one for loop syntax. So it knows that I want to put the snippet of code into this resulting list. So I don't need this extra stuff. All I need is what is going to go in that list. So the snippet of code that will make up each element in my output list goes here. Then I have the same kind of syntax we see for a for loop. We have for, xi, and range. So we have the list we're iterating over, the name of the variable that we use in this statement, and then the for in syntax. Okay, and that basically compacts an entire for loop into this little tiny list comprehension. So here in this example, I want to just get these squares, so there I get them out. All right, it's a very convenient thing. So this is just one example of how to do list comprehensions. Here's another example. Here I want to have the function, y equals x squared. So this code here is for me to print it out. This is actually generating y equals x squared. So I have some x's, 1, 3, and 10. And here I'm computing a list comprehension, xi squared for xi and x. So this is the list comprehension. Then I'm showing you here the zip to print them out. So I'm using my previous, syntax I showed you, zip, So I'm zipping up x and y and printing out each x and each y. So 1 squared is 1, 3 squared is 9, 10 squared is 100. So list comprehensions, very convenient for little snippets of code. If the for loop is very simple, you can just put it into a list comprehension. Now, sometimes we want to do a list comprehension, but we just use it as a way to fill up a list. So here, I'm not actually using this variable. So I just want to make 4 zeros. Now, obviously, we know we could use the numpy zeros command to make 4 zeros. But if I don't want to use numpy, if I just want to do this in Python, I can make a for loop. But inside the for loop, all I do is get a 0 for each time through the for loop. So I don't need an internal variable. I don't need to keep track of this range 4 here. So remember, this will give me 0, 1, 2, 3. I don't care about that because I'm just giving a 0. So whatever this is doesn't matter. So in Python, it's kind of a convention that we use the variable underscore to indicate to the reader of the code that I'm not using this list. I'm just using the fact that this list has 4 elements to fill up to make 4 zeros. Okay, so this is not syntax. This is a convention that I use the underscore variable to indicate don't worry about what I'm doing in the for loop. I'm only repeating this statement over and over again. Okay, so using an underscore indicates as a convention to the reader that I'm not using the list that I'm iterating over. I'm just using the length of the list. The only reason this statement here exists is because I want to do something 4 times, and that something is give out a 0. So it's a long way of just saying I'm repeating 0 4 times. Cool, so list comprehensions, very convenient. And you can look at this one here. I won't go through this whole one, but this is just showing in a real example of how to compute the mean and variance quickly using list comprehensions. Okay, so computing the variance requires you to get the mean and then do a for loop over it. But here I can just make it very quick using a list comprehension. Okay, so here's the variance calculation in just 3 lines, very convenient. All right, now you can use comprehensions to make dictionaries as well. So instead of using a square bracket, so this is where the comprehension is, instead of using a square bracket, we use a curly brace. And that says I want to do sort of a quick for loop, but I want the output of the for loop to be a dictionary. Okay. Now to define a dictionary, remember we need to have a key and then a value. So to tell Python what the key is, we put the key, then a colon, and then we have the value. Okay. So then here I kind of want 2 variables. So I do a zip to get myself 2 variables in the loop. Maybe we'll start with a simpler example. Here's a simple example. I'm going to make a dictionary, and I'm just going to do it like this. Okay. So I'm making a dictionary here. So I have my key and my value, and then I have a for loop going on, but it only has 1 element, and it's just making my dictionary. Okay. So this is how it looks. But to make a real dictionary, you need to have multiple, well, you don't have to, but practically we would want to have multiple keys and values. So here they're variables. Okay, so here they're just constants. Foo is the key and 4 is the value. Here they're variables. Where do these variables come from? I'm iterating over 2 lists using that zip syntax I learned about. And the lists are, the first one is 4, 10, and 11. And the second one is the string number of people, the string the number 10, the string another number. Okay, so then the result is that y is making the keys and x is the value. So number of people 4, the number of 10, 10, another number 11. So we can do comprehensions, list comprehensions have a for loop and the result is a list. Dictionary comprehensions have a for loop inside, but the result is a dictionary. Okay, the last little kind of pretty syntax to learn is f strings. Okay, f strings are a lot of times when we're doing string formatting, we want to access variables. One of the cool things we can do is if we put a little f in front of the string, we no longer need to put the period format. What will happen is Python will look at all the variables we have available and make them usable in the curly braces. So instead of using 0:1 or 2:1, sorry, yeah, 0 colon or 1 colon, we put the name of the variable we want and then a colon, and then we can do any string formatting we want. And if we don't need to do any string formatting, we can just put the name of the variable. Okay, so here I have a variable called answer whose value is 4. So then if I put in curly braces answer, it will replace it with the variable value. And then here I can put mean in here, but here I want it to have 2 digits of precision and print it out as a floating point number. Okay, so then it becomes, instead of -3, it's -3.00. So f strings are pretty convenient. Like a lot of times it's tedious to type format, answer, mean. Using the f string, we can access all the variables available in our Jupyter notebook and just use them by name. All right, so those are just a few little, tips and tricks to make your Python easier, be a little more Pythonic, a little bit of advanced stuff that you might see in other people's code. So why don't you try to use them out in your next homework? Thanks, guys.